you guys all know I'm Peter, or Mr. S, and thank you to Teacher Kirsty for filling in for me on Monday. I had parent meeting evening. The topic of today is, well, let's just do this first. So what is the whole point of this unit? It is about solving for unknown sides and unknown angles in triangles. And the stuff that we learn in grade 11, it's all about how to do it in non-right angle triangles. Back in grade 10, the world was good and we could find angles and sides, but we had to use SOHCAHTOA. But now what happens if you don't have a right angle triangle? Well, it turns out there are rules that you can learn about. And so we learned how to find sides and angles previously using the sine rule. We, on Monday, learned about how to find the area of any triangle. And so tonight, we're going to focus on the cos rule, or the cosine rule. And there's going to be one lesson where we focus on the sides with the cosine rule, which is tonight. And then the next lesson will be about how to find the angles. Now, as we look at the cosine rule, it looks a bit strange as we look at it here, but it does remind me a little bit of Pythagoras. And so sometimes I refer to the cosine rule, the cos rule, as Pythagoras on steroids, because it has this extra little bit here. And what you have to understand is that it's really about relative relationships in a triangle. So the best way for me to show you how this works is to actually show you a real example. So if we are using the law of the cosine law, the law of the cos law, or cos rule, is to figure out what is the missing side that you want. And if you have two sides and an included angle, the cos rule is the tool for you. Now, in this situation, I'm going to label my sides using the convention, this being little a, this being little c, and this being little b. And you are allowed to name sides like that. And it's not wrong to say a, b instead of c, but it just, for this purpose, I want to do this. Using the cos rule, I can write down, remember it looked a bit like Pythagoras, I write down a squared is equal to the other two sides squared and added together minus 2 times those other two sides times the cos of the angle between the two known sides. So what this really looks like is, I want this side. What are the other two? Well, then they go here and they go here. Just sort of like, almost like Pythagoras. Then those two sides that were here will also go over here. And then at the end will be the angle between the two known sides. So that will be the cos of 55. Now, to figure out what a is, the problem is I have an a squared. So what I need to do is I need to square root both sides, in which case I get a is equal to 23 squared plus 20 squared minus 2 times 23 times 20 times the cos of 55. I want you to put that in your calculator and tell me what you get. So put that in your calculator and tell me what you get. Oh, welcome to Rulani. Rulani, we are just starting with the cos rule today. And the cos rule is a rule that we use to find an angle or a side when we're given two sides and the angle in between. Have you started the cos rule in class yet, Rulani? I just want to get a sense of how much I need to go over stuff as we start today. And then if we can put the answer that you get, if you plug all these values in your calculator, what are you getting for the length of side A? I'll do it with you. So square root 23 squared plus 20 squared minus 2 times 23 times 20 times cos of 55. Okay, So I get 20.03 centimeters. Okay, so I'll fill you in, Lonnie. So basically what I said is there at the beginning of the lesson that there are three different rules that we use in solving triangles. The previous lessons have been about the sine rule and the area rule. Tonight we're focusing on the cosine rule. And the cos rule looks a lot like Pythagoras with just an extra bit added on at the end. And we need to think about how do we represent this relationship in a situation where we're given a question. And so that's what I did in this first example. But I'm going to do another example before I let you guys loose on this. So in this triangle, you are asked to find the length of QR. QR is this one down here. Now, if I think about the cos rule looking like Pythagoras, the side that I want to find is just going to be QR squared. And then it's going to be equal to another part squared plus another part squared. And then I'm going to say minus 2 times the other two parts. And then it's going to be the cos of an angle. All you have to do is say, look, it's not this one. That's what I'm after. What's left behind? You put a 3 there, and you put a 9.2 there. Over here are just going to be these two sides over there. So 3 times 9.2. And then at the end, you go, what is the cos of the angle between the two known sides? Now, in order to get the actual length, you are going to have to square root both sides here. So again, I want you to use your calculator and tell me, can you find what QR is, which is the unknown side using the cos rule? So pop that in your calculators and tell me what do you get for the length QR. And welcome to Silicane and Arson who have joined us. Welcome. Okay, let me put this in my calculator. What are you guys and girls getting for your value for QR? For those who are just joining us, don't worry, you'll pick it up in the next examples. What did you get for the length QR? If you put, basically, you have to square root both sides in order to get the QR figure here. And I am getting 8.49 centimeters or here. So just to rephrase what the cos rule is, we use the cos rule to find unknown sides or unknown angles. Tonight, we are using it to find unknown sides. And the thing that we look out for is, are we given a side, another side, oh, we use a different color, a side, another side, and the angle in between those two sides. If we're given that, we can work out what the third side is by using this rule that looks a little bit like Pythagoras. So I'll leave that up on the board, but while that you are looking at that, can we please attempt the next question, which says find the length of QR? And because you've given us, they've given us a side, they've given us another side, and they've given us the angle in between, we kind of are, that's telling us we should use the cos rule to figure this out. It'll be, it's a good idea to use that. Also, we couldn't use the sine rule. The sine rule wouldn't work here because we don't have matching pairs, just to point that out. So ask yourself by writing down the side that you want to know is QR, and we write it as QR squared because that's the nature of the relationship. Then you write yourself out this template to help you, and then you have to go fishing to find the values that go in here. So I'm going fishing and I caught a 13. And so actually that 13 is going to appear here and here. I go fishing again. Again, that's a 4, that's a 4. And then I put here, I put the 70. So now, in order to find what QR is, I have to square root both those sides. And in my calculator, I'm just going to put that. And what I want to know from you is what is the value of QR that we are getting? So I take out my calculator, I hit the square root button. I go 13 squared plus 4 squared. I'm using the square button, minus 2 times 13 times 4 times cos of 70. Close the bracket, hit equals. And I am getting 12.22 centimeters, which means that that is this one over here. Give me a score out of 10 for how well you are understanding the cos rule. 10 out of 10 if you understand how to use it perfectly. 0 if you have no clue. 5 if you sort of get it, but you probably need to improve. How are you feeling at the moment? Let the people's voice be heard. Okay, cool. So we're in the early stages of getting used to this new tool. And like any new tool, you need to practice with it before you become a master tradesperson. So let's keep going with the examples and see how it goes. In fact, let me find, let's do a multiple choice question first before I move on to another one. So you are given a diagram written over here. Which of the 4 options is a correct representation using the cos rule? See if you can recognize which of those 4 is the correct one. And then put your answer in the chat, and I'll wait till everyone's voted before I do anything. And welcome to Stephen, who's joined us. So Stephen, what we're doing is we are doing the cos rule today, which is a tool that we use to solve triangles. And there's a very distinctive process that we use, and it looks a little bit like Pythagoras with an extra bit added on. So it's not clear exactly which side I would go for, but I'm kind of getting drawn to the X because I see all these X's down here, but we'll have to wait and see. But what the cos rule says is that side squared, it's going to have this template that students, I kind of think of students should ultimately just memorize. So if I know that that one is the one I want, it's these 2 that are going to go here. And then this is the angle between the 2 known sides. So that will go there. Does that help me identify which of the 4 matches that equation? So which of those 4 do you think matches? Well, I have a cos 51, so I'm going to get rid of that. There's no 2 in B, so it can't be B. So which of the 2 that are left do you think it's going to be? So the people are saying C, and the people are correct. The students of the room have correctly identified that C is the correct answer. Okay, cool. Let's have a look. Okay, don't worry, Amelia, you don't have to share a jam file for now. We'll rather, in future lessons, we'll experiment with that, but for now, you can just leave that off. Okay, next question. If we look at, in fact, let's go to another one. Use that one. Let's go to this one here. Can you work out what the length of BC is over here? And I want you to do this mostly by yourself. If you are stuck, so some people joined a bit later, like Amelia and Stephen. If you have a question, you can raise your hand, and no problem, Amelia, don't worry. If you have a question, raise your hand. Amelia, have you done cos rule in class yet, or is this completely new to you? And Stephen, have you covered the cos rule in class yet, or is this new to you still? Okay, so Amelia, how are you feeling? Do you think you understand the structure based on what you've seen so far, or do you need me to give you a bit more? Can you do this one by yourself, or do you need a bit more guidance? Oh, perfect. Okay, well then you can go through it yourself, and then pop your answer in the chat when you feel like you are there. This is a solo, your first completely solo one. I'm starting to feel like I'm noticing almost like I don't even have to do, some of you should still do the template, but after a while you start to feel like, this is getting a little bit predictable. Watch out for the -2. That's the one that goes missing very quickly. And then you should have the cos of 105. Now I still need to do some calculator work to get BC by itself. So I'm going to give you a bit more time to put that in the chat. What are we getting for BC? Pop your answer in the chat. So Silikani, you asked when are we going to do trig functions? So Silikani, I did do some trig functions in the first week of July. So there are 2 lessons on that. I'm also going to release what's called a top-up slideshow, which includes all the recordings of previous trig function lessons. And so I'm going to upload that to Google Classroom this week, and there will be a selection of previous lessons with like their titles. And so that would be something that I would look at. Okay, and then just keep reminding me until you've seen it, and then also let me know, what about it did you find helpful or not? I might even be able to do that tomorrow, actually. I'll try and do it tomorrow. I'm going to put it on my to-do list because we have lots of previous lessons that we've done on trig functions, but according to the CAPS planner, this is the topic that most students in theory should be doing, although a lot seem to be doing trig functions. So, yeah. Okay, what do you get? I get 28.79 centimeters, and so does Siamtanda and Takeni. So, and Amelia, we are doing solving triangles at the moment, which includes the sine rule, the cos rule, and the area rule. In the first week of July, we did a week of trig functions, but I'm also going to release a whole bunch of the old recordings to you guys on trig functions. These are not trig functions, these are trig rules. So maybe it was just the words that I was using that are different. Give me a thumbs up if you're done with this example and you understand it. Okay. So take a screenshot if you still need more practice, but we will, let's do another one, and then I'll leave the other one up on the screen so that you can still look at that if you're still looking at the answer. So can you please find me the length of km? And then I'll leave the other bit up just so you can see it, just in case. Find me the length of km. It's a little bit more difficult because of the fractions. What would you get for km? Start by writing out your template. You have a side, you have another side, and you have the angle in between, which means the cos rule. You know you have that. Let me choose something thicker so it stands out. You know that you are going to have that template. Maybe I should just make this a little bit darker as well. The biggest thing I want you to notice as you are doing more and more examples is the first part feels a lot like Pythagoras. Okay, so you want to find a side, and then there are two other sides left, and it's something squared plus something squared. Then we have minus 2 times those two sides you've just used with the cos of the angle in between the two known sides at the end. So punch that in your calculator and tell me what you get. What are you getting in your calculator? Stephen, what are you getting? Okay, let's have a look. So I'm going to do it with my calculator. Square root 6.2 squared plus 14.8 squared minus 2 times 6.2 times 14.8 times cos of 72 equals, and I get 14.17 meters. So this thing over here is 14.17 meters. And you've worked it out using the cos rule. Okay. Some of you might have made a mistake of not including the minus 2 there. But yeah, we'll see how it goes. Give me a score out of 10 for how you're feeling about this. I want everyone to vote. 10 is perfect understanding. 0 is none. 5 is okay, but needs to improve. How are you feeling about this so far? Yeah, let me speak to Stephen. Stephen, go ahead and unmute yourself and let's have a chat.
Hello, sir.
Hey, how can I help?
Sir, do you mind explaining how I should put it into the calculator? Because I got a different answer.
Okay, so in your calculator, the thing that you may not have done is you may not have included, you need to square, sorry, let me include this. you need to square root this side and square root that side. So you start by going square root. So hit the square root button, okay? Then type 6.2 and hit the squared button on your calculator.
Okay.
Plus 14.8, hit the squared button.
Yes, sir.
Minus 2 times 6.2 times 14.8 times the cos of 72, but you need to close the bracket on the 72, and then you hit equals. And what do you get then?
I see it now, sir. I see it.
Perfect. All good. That's why I'm here. All right, let's do one multiple choice question before we have a break. I want to make it a bit more exciting for you guys. So let's do this one over here. Here is a drawing with a bunch of relationships. Which of the four do you think is a correct representation of the cos rule? So Amelia, your question is, we always have to use this formula. We use this formula in the situation where we are given two sides and the angle between. So if I'm given like this is 13, this is 12, and I'm given that this is 40 degrees, then the correct tool to figure out what the missing side is going to be the cos rule. But if I'm given another combination of information, so maybe I'm given like, I don't know, so maybe this is, say, 80, this is 12, and I'm given that this is 30, and I want to know what that side is, well, then using the sine rule would be a better option. So it's almost like we're learning the correct tools for different situations today. Okay, I hope that helped a little bit. Let's have a look at this. Now, what's sneaky about this is that if we want to use the cos rule, we probably have to use these two sides and the included angle between them. If these are the ones I'm using, it's the 11 that's going to be by itself. So it's going to be 11 squared equals x squared plus 9 squared minus 2 times 9 times x times the cos of 44. And what might have caught some of you is you may probably wanted to use the 9 and 11, but there's no angle between it. So that won't work as a representation of the cos rule. Which option do you think is correct now, based on what's on the screen? Okay, and to Kenny, let us go to you. What do you think it is?
Good evening, sir.
How's it?
I just had a query. I
Okay, go ahead.
I wanted us to do the answer for this one because it looks
Okay.
a bit tricky.
Okay, I like that. I like the way you're thinking. Okay, first of all, let's make sure we've got the correct option. So with B, it looks to me like B would be the correct one. It can't be this one because it's missing the 2. It can't be this one because it is missing something. And it can't be this one because it's missing the x. Okay, so it has to be this. So now the question is, if I want to find what x is, how do I find that? Well, I have to make x the subject of the formula. So let's clean this up a little bit. Let's get 121 equals x squared plus 81 minus 18x times the cos of 44. Okay. I'm now going to move this to the other side, in which case it's going to be x squared minus 18x times the cos of 44. What have we got left? Plus 81 minus 121. So things are getting rather exciting rather quickly. Give me a thumbs up, though, if you followed that, if you followed the rearranging that I was doing. Such a good question. Such a good question. I love it. See, this is why students asking questions actually improves the quality of the lesson. Okay, now I don't know if you can see what I'm doing, but I'm trying to make this a quadratic equation. Now, at the end here, 81 minus 121. So 81 minus 121 is going to give me minus 40. The x squared in front is awesome. I need to do some cleaning up with this middle term. So what I'm going to say is minus 18 times the cos of 44 and see what I get. Now, this is a little bit messy. This is minus 12.948 blah, blah, blah. And then there would be an x here. So this is a bit of a messy question, but how would we actually solve it if we wanted the answers? Do you know what we would do? We would use the quadratic formula. So in the quadratic formula, we would have a is 1, b is this, c is this, and we would use the quadratic formula. Okay. The only other way we could do it would be to take out, it wouldn't work, we'd have to use that based on this thing. Okay, I'm not going to go into that right now because it's a little bit early, but give me a thumbs up if you followed the logic that I was using there. So basically, I was turning it into the standard form of a quadratic equation. Amelia, don't worry. We don't have to go this hardcore that quickly. Okay, let's just do one more multiple choice question. And then, actually, you know what? Let's take a break. Let's take a quick break. So what I want us to do is I just want us to take a speed break. So we're all going to stand up. We know that our productivity goes down if we sit for too long. So all I want is us to do 10 to 15 jumping jacks. That's it. Nothing else, no stretches, no whatever, just 10 to 15 jumping jacks. And the reason we do jumping jacks is they raise our heart rate. That's it. So this is what a jumping jack looks like. I want you to make sure that you are free of anything else. You're not going to whack anybody or any piece of furniture. And we are going to start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 more. 1, 2, 3, 4, 5. And we are good to go. Give me a heart emoji thing if you have your heart rate up from jumping around. I'm amazed at how that blood flow just makes your brain wake up. It's like, it's just awesome. Okay, let's do another multiple choice question. So we are given this triangle that's just hanging out. The question did cut off that these square roots need to go the whole way across like this. Can you identify which of the 4 options would be a correct description using the law of cosines? Which of the following is correct for B? And B is just chilling over here, in case you haven't spotted it. Okay, so we want a b squared. Now, I think I'm just going to write out how I know the law works. So I go 7 squared plus 9 squared, because those are those two sides that I'm using, minus 2 times 7 times 9 times the cos. Now, which angle should I use? Should I use 100 or should I use 34? What do you guys think? I think it has to be the 100, yes. Now, to get b by itself, I have to square root both sides. And I notice here that none of the numbers are matching because they're quite big. So I think I need to start cleaning up over here. So once you start cleaning up, which option looks good for you? A, B, C, or D? Which option looks good for you? 7 squared is 49, and that's 81. So 49 plus 81 is 130. And 2 times 7 times 9 is 126. And that seems to be that. So which option matches that? Well, it's not that one. It's not that one. And there's a plus in this one, which doesn't work. So it must be a minus. So the correct option is B. So if I look at what we've done so far, I think you can all do the cos rule finding the sides in a basic way. So I don't think anybody would struggle to do a basic cos rule question. I need to find you something a little bit more exciting. So that looks a little bit more, oh, we've done, that was the previous question. Let's do this multiple choice question. I really like these multiple choice questions because they force you to think in a way that sometimes, because you have to choose. Okay, which of those 4 options would correctly calculate the value of x? Would it be A, B, C, or D? Okay, so we need x squared is equal to 6 squared plus 10 squared minus 2 times the cos of the angle in between. Is there anything that looks like that? Well, no, but I have to square root, obviously. So I get square root of all of this stuff. And it cannot be those two. And what gives this one away is the plus. There shouldn't be a plus. So the correct answer is A. Okay, you guys smashed that one. That was too easy for you. I think I need to find something a bit more exciting. So that's fine. That's fine. Okay, let's do this one. This is from an old exam. I can recognize it. Now, what is different about this one is we are mixing in 2 other trig rules. You may have to use the sine rule or the area rule or the cos rule, depending on the situation. So, question number 1, 2.1. Find the angle BAC. What tool should I use to find the angle BAC? I want you to identify what tool. Should I use the cos rule, the area rule, or the sine rule to help me find BAC? just to make sure you know where BAC is, it would be here. Okay, now here's the thing. The correct tool to use is actually the sine rule in this case. Actually, no, I lie. Let's have a look. If I want this, is there something that I'm missing? That's 37. You know what? I think we need to find this angle over here first. And if we find that angle and we know that one, we can work out that one. We can't use the cos rule here because we don't have the included angle between the two sides. So I want us to work out what that angle is there. So what I'm going to suggest is if we go back to the lesson 2 that we did about the sine rule, if I want an angle, I write the sine of B on top. What will be below the sine of B? What will be below the sine of B if we think back to the sine rule? It's going to be the side that is opposite the sine of the angle that we're choosing. So it would be the value 16. And that is going to be equal to the sine of another angle divided by the sine of another side. So what is the only other angle we have? It's 37. So below that, we are going to have divided by the side opposite that, we get 11. Now, and this goes back to lesson 2, sine of B, if I bring the 16 across, is 16 sine 37 over 11. And if I go shift sine of that thing, of this whole thing in yellow, which I'm going to put in yellow, I will get the angle B. So can you please find me the angle B using basically this command on your calculator? Go B equals shift sine or inverse sine of this whole yellow thing up here. I'm just using yellow to mean that over there. And tell me what you get for B. One of the more difficult things with the section is knowing what tool to choose when. But in order to do that, you need to get a good understanding of the rule. So I know you know the cos rule now. Now we need to decide when can I use the cos rule. Is anybody willing to give me the answer for this one? Would you like some guidance? If you need a bit of extra help, if I've lost you now, just let me know. Yeah. So I move the 16 to the side, and then I'm going shift sine to get the B by itself. So I'm going to do this now. Shift sine, fraction button, 16 sine 37 over 11, close the bracket, close the bracket. I get 61. I get 61.01. I'm going to round this off to 61 degrees. So I'm going to make this 61 degrees. I want to know, what is the size of angle BAC going to be? What is the size of angle BAC going to be? Yeah, so Stephen has said it's 82, and I think what Stephen has done, 180 minus 61 minus 37 gives you 82, and the reason would be sum of angles in triangle. Okay, this is fantastic news, because in the next question, it says, what is the distance BC? And BC is the length of a side sitting over here. What tool should I use to find BC? What tool would be the quickest, probably, or, what should I use to find BC here? Well, you can't use Pythagoras because you don't have a right angle triangle. So there's no right angle triangle, so you can't use Pythagoras. There's actually two things you could use. You could use the sine rule or the cos rule. But because tonight's lesson is on the cos rule, I'm going to do the cos rule. So we would go BC squared is equal to, now what are the two sides that I'm focusing on? I'm focusing on 11 and 16. So I'm going to go 11 squared plus 16 squared minus 2 times 16 times 11 times the cos of what? What angle am I going to put there? What angle is going to go into that? I think it must be 82. Yep. And then what is my final answer going to be for BC? What's my final answer going to be for BC? So square root we've typed this in a lot today, but hopefully that really gets us comfortable. What are you guys getting for BC? I get 18.11 meters. So 18.11 meters. Last, let's say, second last question of the day. If I want to find the triangle, the area of triangle ABC, what rule should I use? I clearly should use the area rule. And what the area rule states is you can go a half one side times another side times the sine of the angle between those two sides. Now, I'm going to suggest we could use any combinations of sides here, but because we know for sure these are 11 and 16, I'm going to use 11 and 16. And the sine of the angle between 11 and 16 is 82. So find me the area of this triangle. Find me the area of this triangle. So I'm going to make this the last question of the day. So let's go out with a bang. What are you getting for this question? So let's have a look. A half times 11 times 16 times the sine of 82. You should be getting 87.14 meters squared. Meters squared. All right. So at the end tonight, what I did to make it a bit harder was I showed you how when they give you these questions on tests and exams, they don't always tell you what rule to use, and you have to figure out which rule fits what facts. And sometimes you have more than one choice, but in the next lesson, I'm going to show you how to use the cos rule to find angles. And then in the last lesson for the series, I'm going to show you how we mix the questions together and how we choose the correct tool for each job. So that's where we're going into the future. For those who have been asking about trig functions, I will release a top-up slideshow with all trig function-related videos that we've done in the past that could be helpful to you. And when you say trig functions, I assume you mean trig graphs, basically, trig graphs.